That's fine.
It's lose the connection. Okay, so we go back here. So ion polymers will not attach to the promoter. Therefore, 5' to 3' will not happen. How about no glucose, no lactose? What's going to happen? If no lactose, this repressor will be attached to the O. How about the cap? Yes, we do have the cap will be attached to it. However, because the repressor attached to the operator, therefore, this RNA polymers will not attach to promoter. So, this transcription will not happen. Okay? That's a twisted of your mind of 4 situations. And these 2 situations are easily understand. If nothing happens, then of course you're not going to see anything. And here, when you have a glucose, no lactose, of course bacteria start to use glucose. So no attach at all. And glucose and lactose both present, we're going to show you that dioxygrowth curve. Lactose alpha will not use on the top when they no glucose and the lactose both present. No glucose and the lactose present, lactose alpha will start to work. Okay, so it's like a twist in your mind. Now the question is, I have been mentioned it before. Once you have a glucose and have a lactose both present, since the lactose is not going to be starting to do the transcription, how come allolactose will be generated? This is, I mentioned, it's like a chicken and egg, which comes first. And the best answer is, in the bacterial cell, they more or less have some allolactose ready, a minimum amount for the survive. This is, I gave another example. I said, even if you are poor, you still have some penny and some quarter on your pocket. This is, they're ready to prepare. Okay. Nobody knows what are those residue allolactose comes from. This is like chicken and egg, which one comes first. So this is the whole story about that. Okay, so with this one, we'll be using this one to do the review. We're going to come out a question. Since we talk about ion polymers combined with promoter. Once they combine with promoter, there is several situations going to come up. Negative and the positive control both have to work. Then it will start to do the transcription. If none of them didn't work, it's not going to happen. Okay, so let's do a question. The question is here. Let's look at practice question number 2. Let me move here. Practice question number 2. We're going to do this one. Question 39 to 42. Showing below is a nucleotide sequence of a fragment of a double-stranded DNA from E. coli. The stop site of transcription is indicated as A, is a letter A. On the sequence above, show and label the promoter is located relevant to the start site of transcription. Okay, let's do this first, please. Then we're going to talk about it. Okay, how to do this question? You see a bunch of sequences. Okay, let's move just right in the middle, a little bit large. Move right in the middle. Okay, how are you going to do that question? How are you going to find it? Can you say that again?
Lowercase a.
Yeah, lowercase a is the starting places to have the transcription, let's say. And I'm going to ask you, can you show me the promoter where it's located? Because the promoter has been combined with ion polymers. Then what is the sequence for the promoter? No, it's not AGG. So how are we going to study that? Do you still remember? This time, you need to go back to the review, which is we talk about in the class. Okay? This is start and is 1. Sun, sing as you A. What's going to be the sequence? So promoter sequence always is very conservative.
Okay.
The upstream, we have EA, EA, AT. Is that right? That's A, T, A, T, E, A. Don't worry about this one. It's 5 prime, 3 prime. 3 prime, 5 prime. What is this one called? Trigonal box. Okay. This is minus 10 units. Then there is about 6 to 18 gene base between them. You're going to find another sequence right here. PT, EA, GA. What's that? That is minus 35. According here. TTG is here. So, you got here PT, GA, CA. So AA, CT, GT. Therefore, what is a promoter? The promoter has to cover right here. We are looking for this area. This is a promoter. Therefore, when you look at here, where is the promoter? How are you going to label? This will be the sequence you have to label. It's right here. Okay, you have to label right here. You're going to label right here. Okay, of course here the same thing. Just double bonds. So this is a question which is tells you you need to know the trigonal box of minus 10 and the minus 35. Now where are they tested? You need to go back to look at your slides. Go back, look at your slides. Which is I said, one slide is very important. Everybody should know. And not this one. I'm going to go up a little bit. I'm showing you where it is. You're going to have to see is right here. I said that this slide is always very important. This is a promoter regions, a promoter sequence. And this is going to be attached with AEM polymers. Okay, so that's just important slides. Now let's look at the next question. This is a label, when we label. Name the enzymes that recognize promoter sequence. This is easy, is that right? This is so easy. Which one are we going to attach to? Which one are we going to attach to? AEM, polymerase. This is easy. Name the protein subunits that allows the enzyme you identify in question 40 to recognize the binding to promoter sequence. What's that? That's easy. Remember, AEM polymerase, we talk about alpha, beta prime, and omega. Alpha has 2. This is called coenzyme And remember, what else is important? This sigma factor. Is that right? This sigma factor going to help the promoter to find the sequence. And you combine both of these, we call it a Hara index. So what's also here? Name the protein subunits is sigma factor. Is that right? That's so easy. Okay, so 4041 is finished. Write all the mRNA transcript and the labels of 5' to 3'N. On the mRNA transcript, circle the second translation codon, indicate which amino acid is coded by this codon. Okay, how are you going to do it? We have two bands there. Okay, we have two bands there. What are those bands for? The first band is, we call it what? Coding band, is that right? The second band is what? Template bands. Okay, so when we wrote the mRNA sequence, should be exactly the same as above the template bands. The only difference is U will be replaced with T. Is that right? Okay, that's correct.
Let me move this camera.
Just want the people to see it. I want to move this camera. I want to see the. I want to see here. So what happened? Let me just do a little bit design. If I put the color there, that helps. No, not really helps. Let me see the effects. Okay, now what we're going to do? Remember, the long time ago when this exam question, then people start to write from the beginning to the end. Start to write. You don't have to. They're spending a huge time. You made a mistake. Some people say to me, I don't have enough space to write. And I have said you have to read the question, you have to understand. When they're going to start to do the translation, remember some of the gene will be only transcription, they're not going to start to do the translation. Where the place started to do translation and the transcription? AGG, is that right? What is that conservative sequence called? Shai-Dagano sequence. So here you're going to also know the SD sequence is AGG. This will be attached by, recognized by 60S RNA. Then they start to do transcription. And of course later on the translation. So what you're going to have to do, you're going to have to start to label it right here. Okay, start to label at least after this. At least after here. Okay, then you start to label. Okay, let's do it. So I'm going to start to write like this. Go here. So what I'm going to start to write? I'm going to start to write, okay, this is T, this is U, not this. This is U. G, C, P, G, A, G, A, U, G, A, U, C. Then gonna be G, 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 C, G, A, G, A, C. Okay, sorry. A little bit small, too large. Okay, well, we did it here. That's a sequence. My question is, MRMA transcript. On the MRMA transcript, circle the second translocated codon. Indicate which amino acid it is. This is the start of the transcription. At the beginning, they are not started. But we should know, when they translation to the amino acids, always the first one, you should be very clear, is what? Is AUG, is that right? That's the first one. Then, what is the codon for the second one? Is AUC. That will be the second one. Okay? And I'll be able to give you the genetic code if needed. Okay, and you don't have to remember. Then what you're going to do? Let's say I'm giving you the genetic code, then you're going to look for. What is AUC? Is ILE. Can you see it? Is ILE. Okay? So that's going to be the answer. That's going to be the answer. And this question is very well to explain to you minus 35, minus 10, that's a promoter, conservative sequence, attached by an RNA polymerase. So one recognizes the sequence is sigma factor. And then you also need to know when you start to do the translation, you need to find a Shire-Diagonal sequence, SD sequence, which is AGG. And always remember the initiate codon is AUG. What about stop codon? UAA, UGA, and UAG. That's a stop codon. So this question actually is very simple if you understand it. You only need to roll so many. Now, of course, you need to know. This is 5 prime, and this is 3 prime. Okay? This is what you should know. That is the final answer. Okay? That is the final answer.
Your T should be used, right?
Yeah, you should be used. Sorry, that should be used. Yeah, that should be used. Okay, so that's the answer how we're going to do it. That question tests you these two damages, which is put in here. Okay? So we solved this question. Okay, let's look at question number 43 and 45. So below is a partial sequence of an n-RNA molecule. Could this RNA transcript be an mRNA? Why or why not? Then I wrote that. I said, what's the significance of the underlying sequence? I hope people doesn't know, so I wrote it there. So when you see AGG, what is that? I already mentioned it. It's the SD sequence. So is this can be transcribed to be an mRNA? Yes, of course, it could be an mRNA because you have AGG, and they got ready for doing the transcription. What's the deletion of the marked G have any consequences? How are we going to do that? Okay, start from here. You're going to see every 3 circles. UGG, UGU, GUG. Look at the AUG. That's a stop codon, is that right? Okay, now the question is, if this guy I deleted it, what's going to happen?
Yeah, the
very smart. Is that going to happen? Is there any consequences? The translation will be stopped. Because AUG, the reading frame, has been shifted. And then it become what? It become a stop coding. And you didn't even have an initiate coding. Okay? That's the best answer. Very simple, 2 sentences, solve the problem. What would be the consequence of deleting the lowercase here? Okay, this is going to go back. Okay, we're going to go back. Let's say everything is normal. Let's start to do it. Now we're going to have 3 things. Okay, 1, all these 3 things, 3, 4, 5. We're going to mark it. Just mark it different. Okay. This is something bothering me. Let's see it again. CAG, so this will be done. Okay, the question is, this is CAG. If this one deleted, what's going to happen? Of course, the reading frame going to be shifted because the A is right in the middle. Remember, we talk about the first, the second, the third. Only this guy had flexible, called global. Is that right? If you have A right in the middle, you remove it, it's shifted. The reading frame is shifted. So what's the consequences? Then the DNA sequence will be, so mRNA sequence will be changed, which means the amino acid could be changed. Okay? So that's the answer. Very simple. So these are the 2 questions which is used to revise, to review. We have for when we talk about is a transcription translation and how they combine all these models. Okay. And I'll take a picture of those and I'll put on the eCampus if possible. And then I'll do this over the weekend. Then you guys can go ahead to do the review. So I want to put this. So these are the set of the questions we finished. And then I want to move on to the biochemistry stuff. Because this is important. I better say some people still didn't get very well. Some of you already studied very well. So I just have one question right here. This is the first question. You should be very clear so far. Okay, it's a review section. Assuming you already know something. So we're not going to write a chemical again. Okay. Save some time. But we want to talk about the question. Okay. Question 18. You should be very familiar with right now. The calculation of the total theoretical ATP yields aerobic respiration. That's a typical early exam question for you. How are we going to do it? Jessica did that on the blackboard 1 week ago. Some people are still confused. I'm going to be explaining to you. The first thing first, you're going to write on your exam paper. NAD reduced to NAD H2 is either 3 ATPs or 2.5 ATPs. If you're considering oxygen phosphate ratio. Okay. Second, FAD reduced to FADH2. You also should be very clear. This is 2 ATPs. Or 1.5 ATPs. If you're considering oxygen phosphate ratio. There is only one you're going to use it. Either this one or this one. Okay, one of them. Not combination. ADH2. I use 2.5 ATPs. They come in my office and say, why, I want to get my points back. No, I'm saying you don't understand, you're just confusing. Oh, okay, only one set. Either the first one or the second one. Both are fine. So, I like to use the first one. You want to make it difficult, you can do, because it's 0.5. You're not good at math, I'm serious. So don't do the 0.5 of those things. It's difficult. Okay, so let's still do it easy. This is glucose. I don't want to write everything. Okay, go here. You right now should know very clearly. This is called pyruvate. Okay, I'm going to write a little bit large, and not that small. A little line between. Go here. So that's pyruvate. Okay. This is fructose 1,6,5 phosphates. Okay. This section, how many ATP going to generate? At the beginning, there's 2 ATPs gone. Remember there's a branch. So what's going to happen? Something right here. There is an NAD reduced to NADH2. So the 2 places happen is ADP becomes ATP and ADP becomes ATP. You should know where it happens, okay? 1,3-biphosphoglycerate becomes 3-glycerate, 3-phosphorate. And then finally, phosphophenols become pyruvates. How many ATP here? That's 3 ATPs. How many here? Add them up together. Is 2 ATPs. If we add them together, it's 5 ATPs. And this is a branch. So we multiply by 2 equals 10 ATPs. You have -2 here at the beginning. This is so-called investments. This is beneficial area. We add them together. This is -2 add 10 equals